Okay, well, you won't know what went on, but I was having a look at the return of the Harrier base station that we did a couple of years ago. It's called intermittent transmit. First thing I need to do before going any further is to change the transmit trimmer capacitor in the VCO, because that's bound to be what's wrong with it, especially as it's previously been in a nicotine house. So when I came to look, of course, we haven't got any in stock, so I've ordered some from the wholesaler, and I've actually ordered some off eBay. They are part we are not going to recover off scrap sets because they're too susceptible to, I think the word is being knackered. So we're going to start on the next customer set, trade customer box of sets, don't know how many, probably about 3. What have we got here? Oh, we've got an Amstrad 901 of the made in Japan variety. So that should be alright. As long as nobody's done anything weird to it, like they do. I do know we've got an Amstrad 900 coming in. They're always made in Japan. They're always, you don't get on a 900, you don't get channel 9, you don't get retro bleep, you don't get PA. But apart from that, it's the same set. And you're always going to be assured that with the 900 it's a genuine set, because you don't find any cheapos and no clones. So it's the 2nd of October. Amstrad 901. I think it's 30844. Right, let's have a look. So it's the type of connector which you can't get. I think we'll do the safe thing and actually not power it up till we know that it's got nothing silly inside. Will this be a 40-minute tune-up and away it goes? We've actually got quite a lot of sets coming in. We've got a Fidelity 1000 coming in, which the customer's bringing it in person because he doesn't trust the post. So fair enough, kind of thing I'd do. It's not the only time we've had a Fidelity 1000 that the customer cares a lot about. So I know people poo-poo them, but they are very reliable. However, this one, when he brings it, has no operational display, no transmitted audio, but you just don't know what's happened along the lines. So we'll take that off. Can't see anything silly under there, apart from an odd capacitor. And the dropper or ballast resistor is intact. We can lower the value if we can't get 4 watts. Sometimes with the 3.3 ohm one fitted, we can't get above 2.7 watts, and unless I can get above 3.5 watts, we can change that to as low as 3.9 ohms. But if you ever see that clipped out, I've done the demonstration. You'll find this radio will do about 7 watts, but it doesn't do it on 27 megs. It does about 2.7 watts on 27 megs, and the rest of it shoots off into aircraft band on 112 megs. So, oh, look at all this power I'm doing. Yeah, but it's not on 27 megs. Right, get that connected up. This looks in really nice condition, so let's see, because these are capable of very good receive results. So we'll plug our extension speaker test equipment into the extension speaker sockets, and we'll plug our extension speaker into the public address socket. We'll get our crocodile clips on the right way round. These connectors haven't been available for 39 years. 13.8 volts, power on, and we have a dead set. I really ought to find if there's any notes in the is it dead because my clip's come off? It's dead, that's why. So, it's channel 20. Let's make sure we've got RF gain to full, squelch to minimum, tonal do halfway, noisy volume control. Wish I had a clipboard. We'll use one of these magazines that I was reviewing the other day. We're right on top of the sexy lady on the sexy radio mock-up. Let's have another look at her. What was her handle then? Foxy Lady. Where's my pen gone? Right, I've got picture in picture already on. So ready, doing 3.4 watts. Turn the Roger bleep off. .4 watts. And 3.4 watts. It's very well balanced. Low power. It's doing 190 milliwatts. So it's not there non-adjustable, but if we bring the power up, hopefully that will come up as well. So as you probably know, it's supposed to be 400 milliwatts. I've managed to disturb my power connector, which is of course unsatisfactory. We're charging in charging bands, so you know, if it takes me hours and hours and hours to do a set, because I can't put the time into it in one go, don't think the customer pays for that. It's a fixed thing. So we start off with retune and test, and the next level up is service level 2, and then when they start to have got silly modifications, it'll be service level 2 or 3, and so it goes on. So let's see if we can keep this at retune and test. Sometimes there's just one really silly thing like changing a preset, changing about, we'll just charge an extra £3 or something like that, so we don't take it into the next band. Right, where were we? We were looking at current consumption, 1.183, which is quite a lot for what power it's doing. But then it's well balanced, so we'll see. Deviation, we'll take this with a pinch of salt because the deviation meter on this test set needs servicing. We'll check it properly on the test set behind me. Wallow. Helps if we're on channel 20. Wallow, it's 1.5. Frequency is, let's put that on the, where have I put the remote? .79047. Let's see whether we can bring that up. Sometimes the crystals have gone out of spec. Now they're the age they are. Why doesn't my correct trimming tool fit? We use an alternative correct trimming tool. done it. Surprises me. So that's one thing out of the way. That means that we can set the signal generator to the proper frequency instead of a compromise. Right, so with the signal generator on, I've got 100 microvolts on. We want S9 to light. So what does it need for S9 to light? It actually needs 300 microvolts. It's going to be fun, isn't it, with this power? I'm trying to tilt the radio up to show you, and then it costs me the connection. So I'll put 300 microvolts on there. I'm not going to tilt it up again. I'll press transmit, and it's showing 5 bars, and it should show 4. It doesn't have a meter lamp. That wants cleaning. Switches are working. Sockets are working. Let's check PA. Testing 1 2, testing 1 2, 1 2, 1 2, 1. Apart from the fact the volume control wants cleaning. We've got a distorted Amstrad 900 coming, and I think I'm going to talk about an Amstrad 900. It's because it's got distorted received audio. Let's go back to, we'll go to the SINAD meter. Let's see what we can get. Not that good. Oh, better. RF gain wasn't fully up, even though I'm sure I'd done that. That's made all the difference. Gone from not very good to being excellent. 0.35 microvolts. 0.28 microvolts. 20 dB, got some noise there, so it's 2.7 microvolts. I think a retune will bring that up. Squelch is often wishy-washy on these sets. Let's put it to full and see when it comes in. Let's go to the attenuator settings. So I want it to be 100 microvolt, but there's no thick and fast rule on that. 3, 10, 30, 100. It never comes in. See, squelch will never open on tight. Never opens. That's a handy type of squelch. Not. So we'll turn it to minimum. Set the threshold on the radio. Not easy with a dirty control, squelch control. RF gain. I'll be ending up cleaning them all. It's 0.72, which is very good. So that's run through everything. Let's see if we can get a bit more out of this transmitter, or whether we're going to have to change the dropper resistor or ballast resistor. Before it was, if we go back to 1930s, what that does would be called a Beretta, and it was like a valve in those days, often in a metal encapsulation, but fitting into a valve socket, and it looked like a Roman Catholic priest's hat, which is called a Beretta. So that's where that comes from. Nothing to do with anything to do with shooting sticks. So my training, you know, we're going back to the 60s, with me being days away from being 61, and what it means is that what could be called a dropper resistor, I will always call a ballast resistor when it does that kind of function. So, transmitter, yes, that's where we are. I digress. Let's go over to our handy camera 1. We'll go. I'm going to do the VCO, but we'll just go through the transmitter first. So that's definitely peak, 3.5 watts. Definitely peak. So to Mr. Chippy, we probably won't be an on-the-air test today because we're doing a base station and it's already been in. It doesn't need on-the-air testing. And I think he was disappointed. I think he likes doing on-the-air tests. So we can't get any more out of that unless we've got a bit of movement there. No. Go to 3.6 just. So we'll turn the set off, swap the ballast resistor. The other thing is they are only 3 watt rated, those, and although the ones we put in, which are on a 1 year back order, they are sods to get. Now I've got various values here because we have to adjust this accordingly. That's a little bit too low. That'll do. Go down to 3 ohms. It's a 6.5 watt resistor, that. So I find it easier to pull it out first and then we'll clear the holes. It's only because from experience I know exactly where it is on the printed circuit. We do have this sleeving in stock if it's ever missing. Back in the days of my training this was called Sistoflex, but there's other makes probably doing it. These are the Welwyn ones, which are glazed. They're £1.69 each trade. And this is what's on a 1 year back order all the time. Can never get any quantity. You order 50, they send 3. And then they come in trickles. And then by the time you've had 50, you've actually used 50 and you want to order again. I don't need to bother with the lid, I don't think, at this stage because we've done the frequency. So we'll power it back up. Of course we're going to have to reconnect power, aren't we? Okay, so now we've got 4.5 watts. So we'll bring it down. So I need to ensure that we've got peak on here. Which we have. And then we need to turn this clockwise to drop it to 4 watts. Which is there. And then we want it to be within 1 watt. We want it to be within 0.1 of a watt between channel 40 and channel 1. So channel 40 is now 4.0 something, and channel 1 is now 4.1, which is too high. So let's see if we can balance that a bit better. Tell you what we'll do, put it on channel 1, We'll turn this one till it drops a bit. See how that affects channel 40. Bring it back a bit. So we've got 4 watts on channel 40. We've got 4.00 something on channel 1, so that's fine. 4 watts. So it's 4 watts, 4 watts, 4.01 watt. Low power, back to channel 20, which we're on. Wow, that's come up. It's 360 milliwatts. I've never seen an Amstrad do that so accurately. We say Amstrad, don't we? But it's made by Cybernet. Back to full power. Let's look at the current consumption. It's now 1.25. So for another 70 milliamps, we've ended up with an extra half watt. Deviation, we'll connect it to the test set behind me just to make sure we're right. I say we could do with some capacitors changing on the test set, but I'd have a 28-day downtime, and I can't afford to do that. Because of all the organ work, we haven't time to set up other test benches, even though we've got enough equipment for 4. Wow, no, it's well over. It was actually probably 5.5 kilohertz. Wow, that's it. The maximum peak we want is 2.5. See what that reads on my Marconi test set today. Obviously all lies. Wow, you see it says it's 0.8, so it's playing up today. Actually, I think it's 6.5 kilohertz. So it's 2.2 to 2.5 kilohertz. It's things like this that cause bleed over. It's not just people with Fidelity thousands. Radios that are transmitting on 3 channels at once obviously cause bleed over. And it doesn't get louder. You've got to appreciate it doesn't get louder, it gets wider. So it only appears louder on a set with poor selectivity. So you put something with really good filtering, like, well, those team base stations, I don't like them, but this will just go, if you're listening to this on with that kind of deviation level. And the same applies with those grandstand bases. They were good for selectivity and a bit too narrow for anybody who's slightly off frequency. Now we're going to do that VCO. It's done on channel 1 on these sets. Can't remember whether it's floating. Don't think it's a floating chassis on. No, I'll start again. I think we've got a floating chassis. So put earth to a can. Far side of capacitor 9, is it? I'm going to have to get the service manual for this because I can never remember. What I've done, I've just printed off the relevant page. So yeah, so it's 9. It's supposed to be 2 volts in transmit. fact it's 0.7. So there we are, 1.95, and on receive it's 2 volts. So it's high on receive, it was low on transmit. It's very important on this chassis, but you don't always get at the top end, the fourth channel 40. You don't always get what it says in the manual, so don't worry about that. So now we've got because they're interactive, we've got a difference. So we'll need to reset transmit. I'll keep it at the low end rather than the high end. You'll see why later. So now in receive it's 2 volts, in transmit it's 2 volts. So going to channel 40, we're supposed to have 4 to 5 volts, but that isn't right. 3.6 is absolutely fine, and on transmit 3.37 is absolutely fine. So you don't know what meter they used. They didn't say in the service manual what meter they used. So back in the day, when you had the trader service manuals for radios and televisions in the UK, it would always say with VTVM, meaning vacuum tube voltmeter, a high impedance voltmeter. So a digital one is a high impedance voltmeter. Or it would say using whatever, which would usually be an AVO 8. So the industry standard analog test meter in the UK is the AVO 8, which is 20,000 ohms a volt. So of course, when you've got sensitive circuits, it's drawing current and it affects the voltage you're going to get. And this is why I don't know how they're setting this, and they really should have said. So it's experience that tells me that get the transmit end on channel 1, get it right on channel 1, and as long as it's somewhere over 3, it's going to be okay on channel 40. But that's now correct, and as you can see, that was quite a bit out. And what it means is, even if it's working on all 40 channels right now, in a temperature of a building that's 23 degrees, you put this in a cold car at -2 overnight, and you'll find that channels might drop off, or it may not transmit at all. So that's what it's all about. It's very important on this chassis. So that goes for the Mustangs and the Harvards, which have this chassis, and so on. Right, and the NATO 40. So we've done that. We just need to align the fairy lights. I daren't tilt this up. No, I daren't. I want you to be assured that that now says 4. When I go to low power, it should read 1. It does. You'll see it all doing what it does on the air test. However, that was flawed because I did it on channel 40. It's still the same, so that's fine. So that now it was 3 volts plus 0.7 volts. It's now 2 volts plus 2 volts. And that's now 4. So with 100 microvolts on the signal generator, I'll show you the oscilloscope. I'll switch it on as well. Let's have a look for our trace. Turn the volume so we get a sensible trace. And we adjust the detector coil for maximum recovered audio. This is only across the speaker. It's just a very ordinary oscilloscope. Doesn't have to have any megs to it. We happen to be using a 10 meg scope, but it could easily be a half meg scope. Wow, that miles out. Now that can affect sensitivity, as in we may have a better figure than what it really is, but it will improve the legibility. I bet it sounded like one of Doctor Who's Daleks on receive. Or will also improve the squelch performance. Let's go over to the SINAD meter now. See what we've got straight away. Well, it's about the same. 0.3 was 0.35. So improving the detector in this case has actually improved the sensitivity. Right, we'll drop that off and we'll start the alignment of the receiver. Tiny improvement there. No improvement there. Tiny little improvement there through the IFs. Tiny improvement. No improvement. Put a bigger signal on for that one. Let's put a smaller signal on for that one. Not finding a peak on this. Put a tiny signal on. Okay. Now look at this SINAD meter again. So for 12 dB, we now have 0.29. For 10 dB, we've now got 0.23, and for 20 dB, I've got to go on the other scale because we're right at the end of the scale. According to that scale, we're at 1, but according to the next scale up, we're at 1.1. So I'll tell you what, we'll put down 1.1, so it's the worst. So squelch, put that back to full like we did before and see when it opens now. So it still never opens. I'm going to get the signal generator there to 100 microvolts. I'll show you the attenuator. So we've got that at 100, that's at 0. Squelch preset is that one if I recall. Drop the attenuator. Once more than that. That's it. 100 microvolts, that's what I want, full squelch. So now, at the sensitive end, let's turn the squelch down on the radio. Put the signal generator back on, parked at 0.3 of a microvolt. Set the squelch. In at 0.3 of a microvolt. Yes, Mr. Tango, that's an improvement. Now we want the ferry lights to read S9 with 100 microvolts. It does read S9 with 100 microvolts. And it, going up to 300 microvolts, we get plus 30. So that now doesn't need any adjustment. That has automatically corrected itself by realigning the receiver. Good. So I'm going to take a break and do something else for the rest of the day. Later on, I'll come back to this. I'm going to leave it on, make sure it's still on frequency. We'll spray those controls, put the set back together. Jobs are good, and so the set's done. So that has worked out really nicely. Full 4-watt transmit, really good receive. That's what you want. Right, we'll get back onto the Service-Sol switch cleaner. At least you can get into the controls on this type of radio. They're not sealed. So it's that one which we're using. Just make sure the power's off, so when I turn it on and it doesn't come on, just give them a waggle round. Right, power back on. There we go, we're done. Right, I'll turn the test gear off. And we'll go over to the roof aerial. So the roof aerial we use in here is the Antron 99. Mounted just above gutter level on a single story building. Without the optional ground plane kit. And broadside into a concrete tiled roof, and then between us and the test route are several acres of woods. That's why we do the test in deliberately the worst direction. Right. It's still going to be intermittent. Well, no, Roger. Well, there we go. It's what you expect, isn't it? Oh, somebody on another channel. You often get that, do you? I think we've got foreign interference, to be honest. There we go. Right, we'll get that ready to do a test for Mr. Chippy. I know we've covered the Amstrad 901 before in its various versions. It's always nice to see the genuine one and not the rubbish version. Thanks for watching.